The cosmological expansion in quantum physics theory. Cosmological expansion is not treated as an explosion of matter into pre-existing emptiness, nor as a purely mathematical stretching of space-time. Instead, expansion is interpreted as the active growth of the vacuum itself, driven by vacuum decay, layering, and pressure imbalance originating at the universe's birth. Following the collapse of vacuum debris into an unstable singularity, the resulting ignition initiated a rapid outward propagation of newly structured vacuum. This process formed an expanding vacuum bubble within which space-time and matter co-emerged. Expansion, therefore, is not motion through space, but the continuous creation and outward extension of Spacefield layers. Each newly formed region of space inherits the same vacuum energy density as existing space. As the universe grows in volume, the total vacuum energy increases even though local energy density remains constant. This resolves the apparent paradox of dark energy growth and explains why global energy conservation. The observed Hubble expansion arises naturally from this framework. Distant galaxies recede not because they are accelerating through space, but because the vacuum layers between structures are expanding. At sufficiently large scales, this expansion exceeds the speed of light without violating relativity, since no object locally traverses space faster than light. Space itself is what grows. In this model, the so-called Hubble anomaly reflects the intrinsic pressure of vacuum layer formation rather than an unknown force. Expansion is driven by vacuum decay gradients and geometric tension within the space field, not by conventional energy transfer. Gravity, structure formation, and cosmic acceleration all emerge from how matter interacts with this expanding layered vacuum geometry. Cosmological expansion is therefore a geometric and vacuum-driven phenomenon rooted in the universe's origin from decaying vacuum debris and sustained by continuous space field growth. This perspective unifies dark energy expansion and large-scale structure.
Faster-than-light transport is achievable when motion is transferred from the spacecraft to a cosmological carrier field, whose dynamics are not bound by local relativistic velocity limits. In this framework, energy does not accelerate mass. Instead, energy enables coupling to a pre-existing cosmological transport mechanism. The speed of light is the highest measurable speed. Does not mean the fastest a ship can travel to which it is referred with in physics. Space is a vacuum unlike Earth's gravity, which is measurable. Space has no gravity. It is these two quantities the speed of light speed limit is referred by. If the vacuum has no gravity, which slows moving masses when moving through, the speed limit changes. Why? Because no gravity. Relativity also refers the vacuum of space, the vacuum, to be made of the same quality as Earth's filled gravity field. This also is measurable and in the same way. In space, light speed source is conserved, meaning it doesn't stop there. Further acceleration can convey by Newtonian mechanics and dual acceleration theory. The reason for thus is empty vacuum. Silpstream, faster than light speed corridors become reality at the most deepest depths of empty vacuum. Because no resistance. Gravity acts as resistance to moving objects moving through space. Veli changes include resistance gravity fields. In space where resistance is zero, or almost. More energy propulsion can be implied. These are the foundation mechanics on the quantum physics theory that will replace relativity. Rodney Kowecki.
The Kowecki universe. When we talk about what the might look like, we become confused that in a three-dimensional imagery the universe opposing side can never be seen. Not only is it too far in contrast to distance, but nothing we have scientifically can see that far. The idea that the universe is expanding also puts a grip on the problem. Knowing this, we can only feel happen in knowing what we see in what us called the observable universe. That is a profound realization that touches on the ultimate limits of knowledge in our universe. Because of the way space-time is structured, there are actually two distinct reasons why we are likely blind to the opposite side of the cosmic sphere.